Phosphorus 32 is radioactive and undergoes beta decay. So we talked about beta decay in the last video. Here's our beta particle, and the phosphorus is going to turn into sulfur. So let's say we started with 4 milligrams of phosphorus 32, and we wait 14.3 days, and we see how much of our phosphorus is left. You're going to find 2 milligrams of your phosphorus left. The rest has turned into sulfur. And this is the idea of half-life. So let's look at the definition for half-life here. It's the time it takes for 1/2 of your radioactive nuclei to decay. So if we start with 4 milligrams, right, and we lose half of that, right, then we're left with 2 milligrams. And it took 14.3 days for this to happen. So 14.3 days is the half-life of phosphorus 32. And this is the symbol for half-life. So 14.3 days is the half-life for phosphorus 32. So the half-life depends on what you're talking about. So if you're talking about something like uranium-238, the half-life is different. It's approximately 4.47 times 10 to the 9th in years. So that's obviously much longer than phosphorus 32. We're going to stick with phosphorus 32 in this video, and we're going to actually start with 4 milligrams every time in this video, just to help us understand what half-life is. Next, let's graph the rate of decay of phosphorus 32. And so let's look at our graph here. And on the y-axis, let's do the amount of phosphorus 32, and we're working in milligrams here, so this will be in milligrams. On the x-axis, let's do time, and since the half-life is in days, it just makes it easier to do this in days. All right, we're going to start with 4 milligrams of our sample. So let's go ahead and mark this off. So this will be 1 milligram, 2 milligram, 3, and 4. So we're going to start with 4 milligrams. So when time is equal to 0, we have 4 milligrams. So let's go ahead and mark this off. So 1, 2, 3, and 4. So we wait 14.3 days, so this is 14.3 days, and half of our sample should be left. So what's half of 4? It's of course 2. And so we can go ahead and graph our next data point. So there should be 2 milligrams left after 14.3 days, so that's our point. All right, we wait another 14.3 days, so we wait another half-life. So after 2 half-lives, that should be 28.6 days. All right, so we know that after 28.6 days, that's another half-life. So what's half of 2? It's 1, of course. So that's our next point. So after 28.6 days, we should have 1 milligram of our sample. Let's wait another half-life. So 28.6 plus 14.3, right, should be 42.9. So that's our next point. And what's half of 1? It's 0.5, of course. So in here, right, that's about 0.5. And so that gives us an idea about where our next data point is. And we could keep going, but this is enough to give you an idea of what the graph looks like, right? So if I think about this graph, right, this is exponential decay. So that's what we're talking about when we're talking about radioactive decay here. I'll talk a little bit more about exponential decay in the next video, but this just helps you understand what's happening, right? So as you increase the number of half-lives, right, you can see the amount of radioactive material is decreasing. All right, let's do a very simple problem here. So if you start with 4 milligrams of phosphorus 32, how much is left after 57.2 days? Right, so if you're waiting 57.2 days, right, well, the half-life of phosphorus 32 is 14.3 days. So how many half-lives is that? 57.2 days divided by 14.3 days would give us how many half-lives, and that's 4. So there are 4 half-lives. So 4 half-lives here. So we're starting with 4 milligrams. So one very simple way of doing this is to think about what happens after each half-life. So 4 milligrams, if we wait 1 half-life, goes to 2 milligrams. Wait another half-life, goes to 1 milligram. Wait another half-life, goes to 0.5 milligrams. And if we wait one more half-life, then that would go to 0.25 milligrams. And so that would be our answer, because that's 4 half-lives, right? So here's 1 half-life, 2, 3, and 4, which is how many we needed to account for. All right, so that's one way to do the math. Another way would be starting with 4 milligrams. All right, we need to multiply that by 1/2. Right, and that would give us 2, and we multiply by 1/2 again, and 1/2 again, and 1/2 again. So that's 4 half-lives, right? So this represents our 4 half-lives, and that's the same thing as going 4 times 1/2 to the 4th power, which mathematically is 4 times 1/16, so that's 4/16, so that's the same thing as 1/4, and so that's 0.25 milligrams. And so it doesn't really matter how you do the math, right? There are lots of ways to do it. You should get the same answer. All right, you could also get this on the graph if you had a decent graph. So after 4 half-lives, right? So after 4 half-lives, you would be over here somewhere, and so you could just find where that is. All right, so let me use red. All right, so you could find where that is on your graph, right, and then go over to here. All right, so that's approximately right here, and then read that off your graph, and that looks like about 0.25 milligrams as well. So we'll talk more about graphing in the next video.